Right, so you have to say like this, Alex or Ronak, you have to say like this. Distance traveled by an object in a unit time. Unit time means how much time it will be. It may be 1 second, or it may be 1 minute, or it may be 1 hour. So it must be one only. So distance traveled by an object in a unit time will be called speed. Now here we are speaking about speed of sound. And maybe you know that to have a transmission of sound from one point to the another point, we require medium. Without medium, it will not travel. And that too you learned, in vacuum sound will not travel. So now let us try to understand about speed of sound. And sound travels at different speeds in different media. Why it is so? So that's what we have to understand. And to understand, tell me, generally, right. So sound travels in a medium or not?
Yes, sir.
Right. Sound will be created by vibrations or not?
Yes, sir.
Okay. Now see here. So sound is traveling in a medium. And when sound is traveling in a medium, maybe you know that whenever sound energy is given at some point, and whatever the particles which are there at that point will vibrate. That means they oscillate from their mean positions like this. So vibrate to and fro. And when they vibrate, and already I told you, some part of energy which is there will be given to one particle and it increases its vibration. And when it increases its vibration, it collides with the next particle. And next particle, when it collides, energy which is had by this particle will be given to this particle. Now it will vibrate again. So it will vibrate with a greater extent now as it gains some energy from earlier particle. Now what happens is this particle, when it extends its vibration, it collides with the next particle and energy will be transmitted to next particle again. And this next particle again will collide with the next particle. It gives out energy. So like this, sound energy travels from one point to another point like this. And when it travels like this, vibrations are used here or not? Here vibrations will be used or not, as energy was imparted here. And maybe I told you what is a wave in that particular first session. Tell me, what do you mean by a wave?
A wave is a form of energy, and sorry, sir. Wave is a carrier of energy which moves from one point to the other.
Right. Alex or Kavya, can you give answer? What is a wave?
The wave is a carrier of energy.
Wave is a carrier of energy. Very good. So energy will be carried in the form of a wave. And what type of wave sound is?
Longitudinal wave.
Longitudinal wave. Okay. And it is a mechanical wave also. I told you mechanical means which will have a vibrations like this. And here wave is a carrier of energy, and this energy will be carried through vibrations only generally. By vibrations energy will be carried, and that too for a sound wave. And when vibrations are there, to create the vibrations, more vibrations, if one particle is there here and another particle is a distant part, that means a long distance is there between two particles. And when long distance is there between two particles, here in order to give energy by this particle to the next particle, it has to vibrate with a greater extent. But when particles are very close to each other, then what happens? Energy transfer will take place very quickly. And if particles are there at a large distance, the energy transfer will take place very slowly. So that's why generally the sound travels with a different speed in different media. Maybe you know that different speed in different media means generally we take three types of substances. You know that generally how many types of substances will be there? Three types will be there. And what those three types are?
The solid, liquid, gas.
Liquids and gases. And tell me, among solids, liquids and gases, in which of these three forms particles are closely packed?
Solids.
Solids. So again, Ronak only giving. Ronak, stop for a while and let others give chance. Okay?
Okay, sir.
Alex, Kavya, and who are there in speaking mode have to give the answer. Okay? Kavya.
Yes, so solids are tightly packed. The molecules
Right.
in solids are tightly packed.
Solids are very tightly packed. And when solids are very tightly packed, maybe you know that the energy transfer will takes place very quickly. And when energy transfer takes place very quickly, definitely in solid substances, the speed may be higher. And liquids, maybe you know that these are little bit loosely bound, loosely packed than the solids. So that's why the speed of sound will be moderate. That means somewhat lesser than these solids. And in gases, you know that particles are very loosely packed. And when very loosely packed is there, the velocity or the speed of the sound will be very, very less. That means in solids, the sound will be more. In liquids, speed of the sound will be more. In liquids, speed of the sound will be lesser than that of a solids. And speed of the sound will be very less in gases. Why? Because of this tightly packedness. And when very tightly packedness is there, energy transfer takes place very quickly like this. And if particles are apart, then transfer of energy takes place slowly. So that's why observe here. For air, what is the speed of sound? 340 meter per second. Already we learned in previous session. Isn't it?
Yes, sir.
Right. Now observe carefully. Water, what is the speed of the sound in water? 1500 meters per second. And what is the speed of sound in iron? 5000 meter per second. So actually the speed of the sound will depend upon different parameters. And one of the parameter is nothing but the structure of that particular medium which we are taking. And apart from the structure, definitely it depends upon other factors also. And one of the factor on which the speed of the sound will depend is nothing but temperature. And if temperature is more, speed also will be more. If temperature is less, speed will be less. That means temperature and the speed of the sound will be proportional. But here we are speaking not about temperature. So we are speaking about different forms of substances. And remember here, in gases, speed of the sound will be less. And speed of the sound will be more in solid substances. Okay. Suppose if I give one question like this, three materials I will give. One is aluminum. Next one is water.
The aluminium is the answer.
Air. Without listening the question, you can't give answer like that. Okay. My question is, in which of these substances the speed of the sound will be less? Kavya and Alex.
It will be the least in air.
Air. Why air?
Because the particles in the air are very loosely packed, and so the vibration takes longer to pass through, to pass on the energy. Therefore, it takes a longer time.
Right. So now you have to remember the speeds of sound values also. And here remember, iron 5000 meter per second, no? In aluminium, actually, the speed of the sound will be around 6400 meter per second. So very fastly it moves in aluminium. 6,400 meter per second because of a particular property called elasticity. And generally, maybe you know that, do you know about elasticity?
No, sir.
Elasticity. Take for rubber. Take one rubber band will be there, no, with you, generally. And if we apply force and stretch it, the shape of the rubber band will change like this or not, if you stretch it. If you stretch a rubber band, the shape of it will change or not? Kavya?
Yes, sir. If you're pulling it, then it will change, but then it will come back to its original.
Right. If you remove your applied force, then definitely it regains its original shape, isn't it? And if anything regains original shape like that, that particular property will be called what? Elasticity, actually. Okay. So elasticity in aluminium will be more than that of the iron. That's why in aluminium, the speed of the sound will be larger, and that will be how much value? 6,400 meter per second. So now again, to complete, that means to summarize this, tell me, speed of the sound will be same in all the substances or different? Alex?
Different.
Different.
Right, Ronak, when I ask you, then only you have to give the answer. Okay?
Yes, sir.
Right. Alex, speed of sound will be in different media.
Yes, sir.
Why it is so?
Because it's not the same.
Because of?
Because it's not the same in every object. In some it's more tight, in some it's more loose.
Why it is different? Why speed is different in different media? What factor will play important role here? Kavya?
Sir, it depends mainly on the molecules, how close, tightly packed, and how loosely packed they are, because sound travels through the vibrations of these particles. So, if they are tightly packed, then they're passed on much faster. But if they're loosely packed, so it takes longer for the vibration to get passed on, then it takes longer.
Right. Naisha, you are there?
Yes, sir.
Right. Tell me, in which of the substances sound will be large, speed of the sound will be larger?
Aluminum.
Speed of the sound will be larger.
Aluminum.
Naisha, are you there?
Yeah, aluminum.
Tell me.
Sir, I said aluminum. Yes.
Not aluminium. I am asking in which of the substances, not this particular question.
Oh, in solids. In solids.
Very good. In solids, the speed of the sound will be more. Okay. So nice. So now maybe you understood what is the speed of the sound. Speed of the sound is different in different media because of arrangement of atoms, because of difference of density, or again the speed of the sound will depend upon the temperature also. If temperature increases, speed also increases. If temperature decreases, speed also will decrease. So these are the factors which will affect the speed of the sound. But in general, you have to understand like this: in gases, speed of the sound will be less, and in solid substances, speed of the sound will be more. And because of that only, maybe you know that the railway tracks will be there, and railway tracks are made with iron. And maybe you know that to find out whether train is coming or not, we can put our ear onto that railway tracks and we can listen. Even though if it is there very far away, you can recognize that the train is coming. Why it is so? Because the sound will travel very fastly in solid substances, around 5,000 meter per second. So as that much of velocity is there, you can even listen the sounds when a train is very far away. And so that you can think that it may come within some time. Okay. Is it clear?
Yes, sir.
Right. Now, generally sound travels slower than the light. That only we are saying so far. The speed of the sound in air is about 340 meter per second, whereas the speed of the light is 3 into 10 to the power of 8 meter per second. Already I told you in previous session also. So this means the sound travels with a slow speed, but light travels much faster than the sound. And maybe you know that two examples we can speak. And in rainy season, thunderstorms will be there. And when thunderstorms are coming, maybe you know that first you see the light and after that you listen the sound. Why it is so? Thunder and lighting start at the same time, but we will see the lighting first. Why we see the lighting first?
Because light is
Because
faster.
light travels faster than sound.
Right, because the light travels faster than the sound. And here also one more example is also there. When we starting a pistol, that means when pistol is fired, then what happens is first we see the smoke first and after that we hear the sound of it. So here also, why you see the smoke first? So this type of a spark first, because light travels faster than the sound. That's why you can see this, and later you can see, you can feel the sound. Okay. So sound travels slower than the light. Already you know that is a known fact for you. So you can understand with two examples like this.